wanted to have a look at some simplifying using powers of primes in this video. So the first one we've got here, now you could do this on your calculator obviously and get an answer, but if you're in a tech-free part of the exam or you've got more than one mark being allocated for the question, you do need to show how you got it. So when we see the 8 there, we want to write that as a power of prime. So I know that it's going to have a base 2. If you're not sure what your powers of primes are, so if we've got 2, then 2 squared is going to equal 4. 2 to the power 3 is going to equal 8. So I can write this as 2 to the power 3, and it's being raised to 4 on 3. So that means I then can multiply those two sets of indices, and I would get 2 to the power 4, and then I can work that answer out if I'm asked to evaluate it, because I know that 2 to the power 4 is going to equal 16. So you're just showing that you can use that process of changing it to a power of prime and then simplifying. In the next one, we've got another example of where we've got a few powers here, but we've got one that isn't a prime. So we've got our 2 to the 4 is going to stay the same, 2 to the 3 is going to stay the same, but on my 8, remembering is 2 to the power 3, so I write that as 2 to the power 3, and it's being raised to a power of 2. So I can then simplify that as 2 to the power 4 times 2 to the power 3, and this is going to be 3 times 2, which is 2 to the power 6. Then I can add my indices because I have all the same base. So I got 4 plus 3 is 7, plus 6 is 13. So I get 2 to the power 13. In this case, I'll probably leave it in its power form. I wouldn't change it to the number because it'll be a big number. Then I've got down here where I have I've got a 3 there. I've got my 9, which isn't a prime, and my 27 isn't a prime, so I want to change them to powers of primes as well. So my 3 will stay the same. My 9 I know is 3 squared, and my 27 I know is 3 cubed. So you do need to be familiar with what those common powers and numbers that you'll be working with. So your base 2, your base 3, your base 5 are your common ones, and knowing what the squared to the power 3 and power 4 is for them will be quite beneficial. So we get our 3 to the 4n stays the same. Here we've got 2 times 2n, so that'll be 4n, and then we've got 3 times 3n, which will be 9n. Then when we're multiplying, that means we're adding our indices, so we'll have our base 3, but we're going to do 4n plus 4n is 8n, plus 9n is 17n there. Now our last one I just wanted to show because it had some different numbers in there, not all the same base. So my 8 I'm going to write as 2 cubed. My 2 to the power 5 obviously can stay the same, and my 3 to the power 7 can stay the same. On the bottom I've got 9, so I'm going to write that as 3 squared. I've got my 2 to the 7, and then my 81 I know is going to be 3 to the power 4. If you're not sure, you can always do a quick check there. So on the top I can go through and simplify the top and then the bottom. So I've got my 2 to the power 8 times 3 to the power 7. And on the bottom, I've got the 2 and the 4 there, so that's 3 to the 6 times 2 to the power 7. Now I wanted to do my simplifying through top and bottom. So I look at my 2's on the top, my 2's on the bottom. So I've got an 8 here, 7 there. So when I divide, I subtract. 8 take 7 is 1. So I'm left with a 2. Here I've got a 6 and a 7, so I'm just left with 3 to the 1, and then I can work that out as 2 times 3 is 6. Okay, hopefully that was a helpful example.